In this lab, we will continue with step 2 of causal inference using propensity score matching. Propensity score matching is a widely used technique in causal inference. It aims to estimate the causal effect of a treatment or intervention on an outcome variable in observational studies. The core idea behind propensity score matching is to balance the covariates between treated and control groups, making them more comparable. We'll implement propensity score matching manually using Scaland and Pandas. So we looked at the causal inference problem. We are interested in how much a personal experience has a crime victim experienced crime would make them worry about it. That's worry crime. We perform propensity score matching for this purpose in general, process both worry crime and experience crime into binary. Then fit the logistic regression for propensity score estimation. Target variable is experience crime. Covariates are other relevant covariates. Propensity score matching. Use the estimated propensity scores to match treated and control units. Assess balance. Check if the covariates are balanced after matching. Causal effect estimation. Use worry crime as the outcome variable to compare outcomes between treated and control groups. So we'll perform the exact steps in propensity score matching. So we completed step 1 where step 1 is survey data that has already been collected. Age, gender, income, country, and so on. These are covariates. Often our covariates are potential confounders that could bias our results. The intervention equal binary, yes or no, and follow up on our outcome equal binary, yes or no. In step 2, we calculated propensity scores. The propensity score is the probability of receiving the treatment given the covariates. We performed a classification model to estimate the probability for a person to belong to one of the two classes. Experienced crime has a victim, experienced crime equal 1, has not experienced crime before, that is experienced crime equals 0. Hence, for this model, the target variable should be the treatment variable, experienced crime. However, note that ultimately we are interested in knowing the impacts of the outcome variable, worry crime. So the covariates for this classification model should be the independent variables or features that you believe may influence the outcome variable, worry crime. The list of covariates should not include the outcome variable itself. Including the outcome variable in the list of covariates can lead to problems like multicollinearity and secular reasoning. We implemented a simple logistic regression for this purpose. We adapted the code to define covariates so that we only take numeric variables, then implemented the logistic regression model. In this lab, we will look at step 3. So step 3 is match treated and control units. The idea to match a Mrs. X who hasn't experienced crime as a victim before to a Miss Y who has. Recall that simple matching will lead to two little matched pairs. Thus we use propensity score instead to match just a single value. There are various matching techniques. Example, nearest neighbor, exact matching. You can use for propensity score matching. Here we'll use nearest neighbor matching as this is the most flexible yet powerful method. DFPSM of experienced crime dot unique opening close bracket is array of 0 and 1. So the values are 0 and 1. DFPSM of experienced crime dot value underscore counts opening close bracket so gives 95,614 counts of 0 and 25,066 counts of 1. Then we split the data frame into treated and control groups. Let treated equal DF of PSM of DFPSM of experienced crime equal 1. Let control equal DFPSM of DFPSM of experienced crime equals 0. So treated data frame is all the rows where experienced crime equal 1, and control data frame is all the rows from DFPSM data frame where experienced crime column equals 0. Print treated of experienced crime dot head opening close bracket and leave 2 lines, then print control of experienced crime dot head opening close bracket. Gives us the first 5 lines of the experienced crime and equal to 1 and experienced crime equal to 0. That is from treated data frame and control data frame. Treated of propensity score. So let's look at so the treated data frame looks like this, and there is a column called propensity score, and if we place 2 square brackets and then we place propensity score, that will form the separate data frame of propensity score, and this is how it looks like. And there are 25,066 data rows. Let treated points equal treated of propensity score dot values. So we are looking at the array of the values, and it looks like this. Let's look at the control data frame. So the control data frame has the last column which is propensity score, and control data frame of double square bracket of propensity score gives us a data frame of propensity score column, and there are 95,614 data rows. Let control units equal control of propensity score dot values. From scipy.special import ckd tree. Build a KD tree for control group. Let tree equal ckd tree of control points. And control points are all those is the array of propensity scores for which the experienced crime equals 0. Printing the tree gives us tree has a function for t index, comma t row in treated dot iteros open and close bracket. So t index will be the index of the of each rows, and t row will be the rows of the treated data frame. Query the tree to find the nearest neighbor. So let underscore comma c index equal tree dot query of T row of propensity score. So T row of propensity score gives us the propensity score of each of the raw values in the treated data frame. And treated data frame are all the rows containing experienced crime equal to 1. And tree.query gives us two values. Let's print the underscore comma C underscore index. So we can see that it prints the propensity score and the index, the nearest neighbor index. So I'll just show you a treated data frame. It looks like this. And it contains all the data rows where the experienced crime equal to 1. And these are the propensity scores. And the tree that is formed is for the control points. So what it does is that this tree.query finds the nearest neighbor in the control points. Nearest neighbor in the control points array. Nearest neighbor in the control points array, and control points array is the array of propensity scores for which the experienced crime equals 0. So for example, the nearest neighbor for first row of the treated data frame is this value 1.44 and so on times 10 to the power minus 5, and the index is 53,412 and so on. Control dot index location, say let's look at the index location 43,431. 3,431. So control data frame, let's look at control data frame. Control data frame is the rows which contains experienced crime equal to 0. And control dot index location 43,431 gives us these values. And when we want to print the name dot name, it will print 56,959. Let meshed pairs equal Kelly braces. Now when we see the Kelly braces, it forms a dictionary. For T index, comma, T row in treated, comma, treated dot iteros, open and close bracket, and then the colon, query the tree to find the nearest neighbor. So let underscore, comma, C index equal tree dot query of T row of propensity score. So it finds the nearest neighbor in the control data frame of each of the propensity score in each row. Get the index of the control sample, matched pairs, bracket T index. So matched pairs, bracket T index. So T index is the index of each of the rows from the treated data frame. So matched pairs T index. So matched pairs is the empty curly braces for a start, and the position, the location is T index. Let it equal to control dot index location of C index dot name. So control data frame and the index location is C index, which we got from here from the tree.query command, and dot name. And printing matched pairs prints the T index and the control dot index location of C index dot name. So index for the okay, so for the treated data frame, each row index is matched to the index in the control data frame. So the index row 8 is matched to the index 70,441 in control data frame, and so on. Treated dot head gives us this. Okay, so now matched pairs dot keys, open and close bracket. This lists all the keys of from the matched pairs dictionary. So all the fetched values, all the indexes of the treated data frame: 8, 15, 16, 17, 20, and so on. Now we get matched data. Let treated matched equal dfpsm dot location of matched pairs dot keys, open and close bracket. Let's look at dfpsm. So dfpsm contains all the rows having for experience crime equal to 1 and also 0. So for example, dfpsm dot location 8, so this is for the index 8, gives us these values. So for each of the matched pairs keys, we will look at the location of that keys in the dfpsm, and we let it equal to treated match. So treated matched is the dfpsm rows of matched pairs dot keys. Now let's look at matched pairs dot values. So the keys we have used, and these are the values. Get matched data. Let control matched equal dfpsm dot location of matched pairs dot values open and close bracket. So these are the control groups. This is the all the data rows from the control um, data frame. Okay, so these are these values. So now we see that treated matched is gives us 25,066 data rows and 62 columns, and control matched gives us the data frame of 25,066 data rows and 62 columns. Now this cell does the same thing, but we are putting a definition. So to search for nearest neighbor matching, the inputs are treated in control. We are performing in the definition, and we returning matched pairs. So to perform the matching, we just have to call the nearest neighbor matching definition, and we need to input the treated and the control data frame. So we don't need to do it any more, because we have done it over here without the definition. But we can still perform this, and that will give us the same values.